Hey everyone, my name is Kaleb and Naveed, and this summer I'm working in the Argo AI Center for Autonomous Vehicle Research, and my project is trajectory planning for autonomous vehicles using reinforcement learning under noisy observations. My mentors are Dr. John Dolan and his PhD student Ezekiel. So a brief introduction about myself. I was born and raised in Lahore, Pakistan, but I moved to Hong Kong for my bachelor studies. And currently I am a rising junior at the Hong Kong Polytechnic University, majoring in electronics and information engineering. Apart from robotics, I really enjoy playing cricket and hiking on the weekends. So in my project, we're basically working on the trajectory planning problem, and we're using hierarchical reinforcement learning for that. We're also considering the incomplete observations which might occur due to noisy perception system of the car. So in the traditional RL, agent does an action. Based on that action, a reward is generated, and through that reward, a policy is generated for each state. But in the hierarchical structure, instead of learning policy at one level, we divide the problem into meta goals, which is options, and the sub goals, which is low-level actions. So a separate policy is generated for options network, and a separate policy is generated for the low-level actions. In our case, we are using a scenario of lane change maneuver where a car has to do a lane follow and might have to wait for the target lane to clear, and then it does a lane change maneuver. So this is some of the implementation in the carless simulator up to this point. The first one is car doing a lane change maneuver, and the second one is car following lane or waiting, which is another option for a network. So for the benefits of our hierarchical structure, definitely it can be reused again for multiple scenarios because of its modular design, and it has also shown faster convergence rates. For my current work, I am training a hierarchical structure combining the two options, and my model is actually under training right now. I'm also adding some of the safety constraints like the jerk minimization to make trajectory more smooth. And finally, I'm adding an LSTM layer to consider the noisy observations by feeding some particular number of previous steps into the network. In the end, I just want to thank Ms. Rachel and Dr. John for their tireless efforts to make RIS possible this summer. I'm also thankful to my mentors, Dr. John and Zekrin, for their advice and their time. In addition to this, I'm thankful to Mr. Alex Choi for giving me resources during the month of July to facilitate my project. Thanks for listening.